Sir, please confirm everyone. Am I audible? Is my voice is clear? Please confirm so that we will start our session.
Yes, sir.
Requesting everyone to please respond. Right. Sir, in last videos, I think we are talking about recursion. So what is mean by recursion? Why we need to go for recursion? What is the syntax of recursion with some small examples? Okay, even applications, mathematical interpretation of recursion we have started. We discussed. Now we need to go for the actual content, memory management in recursion. So this is the very important topic, and some people are going to get confusion how this memory is going to be managed in the recursion. Listen carefully. The disadvantage of recursion is nothing but it is going to it uses more memory, sir. Okay, memory wise it is very disadvantage because it is going to maintain one data structure. All the method calls whatever we are making, those data will be stored inside one data structure called stack. That's why it is going to use more memory. And it uses stack data structure. Which data structure it is going to use? Stack data structure. So what is the technique that we are going to follow in the stack is nothing but remember it is LIFO, last in first out. Anyway, we will discuss about this in our upcoming classes. So this technique is called as what? Last in first out. Means what? The item or the activity which you are performing last will be the activity that you have to revoke back, or I can say the item which is inserted at the last will be the item which is going to remove first. Suppose consider stack is something like in this representation it will be there. Consider I want to print that the previous program somewhere I covered, right? For example, if you listen, sir, if you understand, like we have taken a function, okay, and if the value of n is equal to 0, something like that we have written, and we are printing some message called something like ABC, something like that, and we are going to call fun of n minus 1. And if you are calling fun of 3, then what will happen? First it is going to call for first time when it is invoking that entire data n is equal to 3, and such type of information will be stored in a stack frame. This one is called as a stack frame. Okay, this one is called as a stack frame. Like it is going to maintain the complete information. Suppose this n is equal to 3, it got executed and it is printing some content, and we are again calling for n minus 1. Then again it will be called, right? So in this case what will happen? With n is equal to 2, whatever data is required it will maintain. Again for n is equal to 1, whatever data is required it will maintain. And when n is equal to 0, what we are doing? We are doing some termination, right? So up to this the method call will be stored in this state. Like this it will be stored. But what is the latest method call that we have made? N is equal to 0. That will be removed from the stack once if the total application got completed. And after this it is going to come back here, and after this it is going to come back here. Do you know this process, especially this process, we are calling it as recursion. Okay, this process we are calling it as a recursion. And this is nothing but, okay, this is nothing but normal recursion. Whatever we are doing in this process, it is nothing but recursion. And once if you come back, this is called as a backtracking. This is not recursion, sir. This is called as a backtracking. Okay, so once if you are coming back for each and every iteration, then it is called as what? Backtracking. So here we are going to concentrate on recursion only. After completion of recursion, the next chapter what we are going to discuss is nothing but backtracking. There I will give the complete information about backtracking, how you are going to work with backtracking, all these things. So the recursion is nothing but to give input for backtracking. Okay, so all the method calls, how it is going to be stored in the stack is nothing but recursion. And once if you come back by deleting the values, that process is called as combination of recursion and then backtracking. So this entire thing will be maintained by one data structure. What is that data structure? Stack data structure, which follows last in first out. Last method call will be available the first. Okay, last method call will be available first. That's why we are going to see the some practice questions. There you can guess the output how it is going to work. But keep it in mind, whenever you are using stack, there is one internal data structure which will maintain. What is that data structure? Called stack. Okay, next. And next one, sir, stack contains, just already I have given this information, let me add in the document. So stack contains the complete information. Okay, the complete information about function calls with parameters. It is going to contains the complete information about function calls with parameters. It is going to have the total information, sir, with parameters. Okay, whatever values here you can see, n is equal to 3, n is equal to 2, like this I have written, right? This information is really existed in the stack. How to get that information also I will show you with the help of example. So this is nothing but how internally it is going to maintain. Suppose if you have more calls, more frames are required. Every frame is going to store some information, right? That's why it uses extra space. That is the very disadvantage what we have in our recursion. Beyond that, nothing. Sir, can you please confirm, is it a clear memory management how we are going to use in the recursion? I request everyone to please confirm, is this memory how it is going to be used in the recursion? Is it clear
Sir,
for you people?
sir, the concept of
Yes, sir. Yes, sir.
LIFO is just to signify the recursion and backtracking, right? Or
No, no,
anything
no,
else?
no. Forget about LIFO, sir. Actually, recursion uses this backtracking and these concepts. Stack data structure will follow this technique. So whenever we are talking about the stack, we have in syllabus, stack is there, queue is there. If you
Okay.
take a queue generally, what is the meaning of queue? You can see some way, some persons are standing on queue. Means what? The person who came first, he is going to get the first chance, right? That
Yes.
is the technique, that is the technique.
Okay.
Stack means what? The person who is coming last will get chance first. Best example you can see in your kitchen. If you want to arrange the plates, so you are going to put some 50 plates. Which plate you will remove first?
Which is
The
means
last one.
last
Yeah,
one. Yeah.
last whatever you have put, then that is going to, you are going to get. That is
Old
the
example, CDs. Fan of
Ah,
CDs.
yeah. You can see deck of CDs, and especially girl students. So they are going to put bangles to their hands, right? So it is nothing but a stack only. One side open. They what which bangle they have inserted last. So they have to remove that bangle first. That is a technique, sir. Okay.
Okay.
So
Okay.
why this recursion is going to use that kind of thing? Because of backtracking purpose. When we are keep on moving, if you not getting solution, then you have to come back. So how you are going to come back? Wherever you left, from that point you need to come back. Because of that reason, they are going to maintain stack. Okay,
Okay. Okay.
right. I request everyone to please confirm, sir, clear, because if it is clear, I'm going to start programming now. So you
Yes,
people will get clarity once if you see
yes,
the
sir.
examples. For and while loop data storage in which structure? Those are not data, they are not going to use any data structure. They are going to follow the normal programming technique. Okay, they won't maintain any data structures. Right now, we entered into the actual content. Now we are going to see the recursive programs. Sir, do you know, before giving the heading, I'm going to take one example for you to understand. What is the example is, I want to take two cases, factorial of the given number. I want to calculate factorial of the given number. This is the first task which I want to do now. Okay. And the second example is nothing but I want to take Fibonacci sequence. Okay. So Fibonacci sequence or Fibonacci number. I want to get a Fibonacci number. Sir, first I will give theory part, one or two examples. Suppose if n is equal to 4, can anyone tell what is the 4 factorial, sir? Yes. What is the
24.
4 factorial?
24.
24.
Yes.
24.
What is the n is equal to 3 means what is its factorial?
6.
6, sir.
If n is equal to 0, what is the factorial?
1.
1.
Yeah.
And coming to Fibonacci sequence, do you know there is one special sequence is there? So first number is 0, second number is 1, third number is calculated by adding these two numbers. That means by adding 0 and 1, we are going to get the next new number, which is nothing but 1. By adding 1 and 1, we are going to get the next number called 2. By adding 2 and 2 and 1, we are going to get the next number, which is nothing but 3. So like by adding previous two numbers, we are going to get the result. Okay, so this concept is called as recursion, sir. I mean Fibonacci number sequence. Sir, in this case, if your input is 4, sir, fourth Fibonacci number they are asking. Fourth Fibonacci number they are asking. Sir, it is 0th Fibonacci. Since it is a sequence, it will be stored in the form of array. 0th Fibonacci number, first number, second number, third number, fourth number. We have 3. If your input is 3, then they are expecting output as a 2. If your input is 1, so they are expecting output as a 1 second. Yeah, right. Sorry. Sir, now you can see we are getting when n is equal to 1, we are going to get the first Fibonacci number. And when n is equal to 0, we are getting 0th Fibonacci number. This is nothing but the concept what we have. Sir, for this, we have to write recursive program. First, I will write for factorial. Listen carefully how I am going to write the function. Sir, first I will define the function. Okay, first I will define the function. How I am going to define the function is, you can see here. So DEF definition. So factorial, which is taking a number n. Okay, so we have to write some condition that I will write later. And I'm going to return n into, okay, function of n minus 1. I'm going to call like this. Now observe carefully. I called for factorial of 4. What will happen? It will call n into, that means 4 into, it will call for factorial of 3. So again it will call, so 3 into, okay, 3 into, so factorial of 2. So again it has to call 2 into factorial of 1. Okay, again we are going to get 1 into factorial of 0. Remember this. Then again for n is equal to 3, what will happen? Factorial of 3. So 3 into 3 minus 1 will become 2. And here 2 into 2 minus 1 will become 1. And 1 into 1 minus 1 will become 0. Sir, do you know this process will continue? And when you are taking factorial of 0, so 0 into again factorial of something like this we are going to calculate. But I will stop when the value of n is equal to 0, we are going to stop. In this particular point, I need to stop. Okay, in this particular point, I need to stop. And it will return. What is the 0 factorial? 1. What is the 0 factorial? 1. What is the 0 factorial? 1. Have you observed? It is called as a finite recursion. It will start at any position we don't want. But when it is going to stop, when the value of n is equal to 0, we have to stop. That condition is called as base condition. Our next topic is nothing but this one only. What is a base condition? Sir, we have to write a condition which should terminate our recursion. So one critical requirement of recursive functions is the termination process, the termination point. Okay, so or I can say this is nothing but what? Base condition or base case. Okay, sir, every recursion program or every recursive function, okay, must have a base condition or a base case to make sure that the condition will terminate. The condition will terminate. Okay, so will terminate or the recursion process will terminate. You have to write base condition in this case. Sir, missing the base case results in unexpected. Okay, unexpected. I think already we discussed about this. Unexpected behavior it is going to return. Already we have seen this, sir. Something like we are going to get recursion error. Okay, we already discussed about this point. So for any program, base condition is very, very important. If we are not writing a proper base condition, then what will happen? That program will lead to infinite execution. I think, friends, you people got very clear clarity about what is mean by base condition, how important this base condition is. Sir, if everything is clear for you people, I will start implementing these two programs now. Can you please confirm? Is it clear? Any doubt up to this? Can you please confirm?
Clear, sir?
Right. Now I will write this program. Listen carefully. So I am going to define a function called fact, which will take a number n. It is going to return n into fact of n minus 1. So now I am going to call fact of something like 4. So what answer we are expecting? 24. Is it going to return 24? No, because we have not written base case, right? So what is happening? Sir, it is going to raise recursion error. So previous line repeated 996 more times. Okay, that is the problem. Now I am going to check the condition. Array, if the value of n is equal to 0, I will return the result as 1. Otherwise, I am going to return n into fact of n minus 1. Don't write any else here. Even if you write else also, nothing will happen, because whenever it encounters a return, the control will come to the original position. Okay, sir, we are returning 1. That means it will come out. So here we are returning n into n will be stored in the stack, and this method call will be stored in the stack, and the fact of n minus 1, again it is going to call it as a fresh method. Again it is going to call it as a fresh method. Okay, now we will check really whether we are getting the output as 24. Sir, we got a 24, right? Yes, my program is perfect now. Now you can ask, so factorial of 3, it should return 6. So I need to get factorial of 2. Sir, it should return 2. Okay, it should return 2. So factorial of 1. Okay, it should return 1. Factorial of 0, it should return 1. Like that we are going to get 26, 6, 2, 1, 1. Like this we are getting. I think you people got very clear clarity how we can able to implement a program to find factorial of the given number. So if you want, just I will write that method calls also. Listen carefully. Okay, so function of 3 for third factorial I am taking. So what will happen? 3 into, so factorial of 2. Sir, this entire method information will be stored in the stack. Okay, so initially we are calling for factorial of 4. So where your n value is 4. Next time it is calling for 3. So your n value is 3 and it is calling for fact of 3. And it will be called for 2. So n value is 2, fact of 2 it is calling. So then what will happen? So it will be called for n is equal to 1. Then we are going to call for n f of 1. Okay, so then when n is equal to 0, so we are going to call f of 0. In this case, it is returning. So you can see here. So 2 into fact of 1 we are calling. So 1 into fact of 0 we are calling. Whenever n value is equal to 0, it is returning 1. 1 into 1. In this method call we are going to get. Who called this? F of 1. So with which value? N. So that's why here we have n. 1 into 1. So it will return 1. Who called this? For them it is going to return 1. Then who called this particular functionality? It is coming back. Who called this particular function? F of 2. So when f of 2 is executing, what is the value of n? N is equal to 2. Sir, 2 into this value already returned, it is nothing but 1. 1 into 2 will become 2. So that value will be written here. Sir, who called this? When n is equal to 3, we got this particular approach. Sir, 3 into 2 will become 6. Sir, who called this? Who called this? So n is equal to 4. N is equal to 3. I think 4 is not there, sir, here. Sorry. Okay. So then who called this particular? For them, it is going to return 3 into 2, which is nothing but 6. So like this, recursion is going to work. I request everyone to please confirm. Is it clear now, this recursion process? Sir, is that error is a standard error? I mean, repeats every time? Yeah.
Sir, if and else loop, if we take, is it going to work or not?
Mm-hmm.
If and else loop. In the else
If
loop,
you write
if
else also, it will work.
okay.
But never recommended, because even if you take, what will happen? The control will anyway comes to the fourth line only, right?
Right.
Even if you take else also, it will come to fourth line. Even if you are not taking else also, it will come to fourth line. Because so here, if some statements are there, if there is no written, then we can write in the else part, because we can't give guarantee. But since
Yes,
written
yes,
is
yes.
there, if this condition is satisfied, it never executes.
Right.
That's why we can write directly. Sir, please respond. I request everyone clear up to this, so that
Sir,
I
we are
will speed up.
considering
Yes,
f
sir,
of
yes, sir.
0. Sir, we are considering f of 0 as first and f of 3 as last.
Yes, but no, in our point of view, f of 3 is first, f of 0 is last, right?
But you
I'm
said
calling,
last in, first out.
which is last inserted, f of 0. That one only came first. Here you can see, at the time of moving the values, I came in this direction. But when we are calculating, we are moving in this direction, if you see. So this is the last inserted value that we evaluated first. Based on this value only, we got this value. Based on this value only, we got this value. Based on this value only, we got this value. Got it?
Yes.
Right. So that's all, sir. I'm not going in detail with respect to recursions now. From now onwards, directly I will write the code. Let us see Fibonacci number. Sir, how you can able to write a program for Fibonacci? Sir, here I am going to define FIB function, which will take a number. So here, what I am going to do is directly I am writing base condition. If the value of n is equal to 0, I will return 0. So if the value of n is equal to 1, I will return 1. Sir, otherwise I am going to return FIB of n minus 1 plus FIB of n minus 2, because it is a Fibonacci sequence. So you know very well sum of previous two numbers. Now I am calling FIB of 5. I am explaining a long result, sir. So what is the FIB of 5 here? So 0th Fibonacci, first Fibonacci, second, third, fourth, and then fifth. I am expecting the result as a 5. Otherwise, I will go for 6, which I am expecting 8. Now see this diagram. Actually, we are not calling one time. We are calling two times. That's why. So when your n value is equal to 6, so it will call for f of 6 minus 1, which is nothing but 5. And it will be called for f of 6 minus 2, which is nothing but 4. Sir, again it will be called two times, right? Again it will be called two times. Sir, here f of 5 is going to be called like f of 4 and f of 3. Sir, this will be called for f of 3 and f of 2. And this will be called two times, this will be called two times, this will be called two times, this will be called two times. So in this case, we are going to get f of 3 and f of 2. In this case, we are going to get f of 2 and f of 1. So in this case, we are going to get f of 2 and f of 1. In this case, we are going to get f of 1 and f of 0. Whenever 0 or 1 is coming, that is the base case. Right? Rest of the things are not base cases. So we can expand this. So f of 2 and then f of 1. And again, this will be calculated by f of 1 and f of 0. Until getting the base case, you need to write. Here you will get f of 1 and then f of 0. And here we are going to get f of 1 and f of 0. So here we are going to get f of 1 and f of 0. Like this we are going to have. Sir, all values expanded, right? Now what will happen? Sir, you can see this is going to return 1. Sorry, when f is equal to 1, I mean when n is equal to 1, it will return 1. This is going to return 0. 0 plus 1, 1 it will return. F of 1, 1 it will return. 1 plus 1, 2 it will return. And here it will return 1. Here it will return 0. 0 plus 1 return 1. 2 plus 1 is going to return 3. And here it will return 1. And here it will return 0. 0 plus 1 it will return 1. Here it will return 1. 1 plus 1 it will return 2. 3 plus 2 it will return 5. Now here it will return 1 and it will return 0. So 0 plus 1, 1 and it will return 1. 1 plus 1 it will return 2. And here we are going to get sir, it will return 1 and it will return 0. 0 plus 1 return 1. 2 plus 1 return 3. So 5 plus 3. Who called this? For them it is going to return 8. Is it our expected result? Yes. So in this case, we are going to get a big stack trace. Right? Initially, we are calling for f of 6. F of 6. Sir, f of 6, first it will expand this one. Okay, f of 5. So that f of 5 again will expand f of 4. Okay, that f of 4 will expand f of 3. So f of 3 will expand f of 2. F of 2 will expand f of 1. Then it will come back. F of 2, one instruction completed, one more instruction is pending. That is nothing but f of 0. Then here this expansion completed, this expansion is pending. Like that, it is going to store the complete information in the stack, sir. As of now, don't get confused. Stacks we are not going to use in these examples. Directly you can see from the diagram. Okay, where stack is required only in the backtracking, that also you can just do for imagination purpose. Can you please confirm? So is it clear? Yes, Sahan is asking, that is the why so much memory. Yes. Here also we can do this one in the shortcut. So we can reduce the number of calculations here. That concept I think you remembered. There is one concept is there called dynamic programming. So to reduce the number of overlapping calculations here, we are going to use dynamic programming that we will discuss in our last unit or after recursion somewhere we will talk. Okay, sir, clear? Please confirm how to calculate these two. Is it clear for you people? Sir, please confirm so that I will go for programs.
Yes, sir.
And let us execute whether we are getting 8 or not. Yes, we are getting 8. This is the way how you can able to make recursions. Now in the recursion, there is one special concept is there called tail recursion. So what is mean by tail recursion? Okay, sir, a recursive function is called tail recursive if the function does not do anything after the last recursive call. Listen my words carefully, very important terminology only for theory purpose. So a recursive function is called tail recursive if the function does not do anything after the last recursive call. That means once if the all recursive calls got completed, if it is not doing anything, then it is called as tail recursion. I will take one example and I will show you how it is working. Okay, one second. Hello. Good evening, Muskan madam, చెప్పండి. Yeah, sir, I will take one example to understand this tail recursive. Listen carefully. Sir, I'm going to define a function. Okay, I'm going to define a function def fun I'm taking, which will take the value of n. So if your n value is less than or equal to 0, simply I'm going to return I'm not doing any task. Later I will print n and n is equal to empty, and I'm calling fun by passing n minus 1. Sir, I'm calling this function by passing the value as a 3. Now listen carefully how this function is going to execute. Sir, first time we are calling with f of 3. F of 3. Sir, what this function is going to do? Sir, it will print 3. It will print 3. It will print 3. After that, it is calling for f of 2, right? So inside the stack, what it is doing? Sir, function 3 we have called first. Internally, this function is calling function 2. Okay, next what will happen? Function 2 is going to print the value 2, and then it is going to call function 1. So it is going to call function 1. Okay, now what will happen? Function 1 is going to print 1 and it will call function 0. Sir, it is going to call by passing function 0. So whenever n is less than or equal to 0 came, we are returning. That's all. The process got stopped here. What is the output? Print statements sequentially we got 3, 2, 1 as output, right? Let me check. Let me check. Is it returning 3 to 1? Yes. Sir, do you know in this program what is the need to use this stack is question mark. Why we need to go for recursion here? Never, because if you are keep on storing the values, again there is no chance to come back. Of course it will do internally, but after this last call, is it calculating anything? No. At least is it coming back to the original positions? No. Then these kind of recursions are called as tail recursions. After the method call, if it is not doing any activities, such type of method calls are called as tail recursion. Sir, here stack data frame is useless, right? Because even though we are using stack, what is the advantage? Nothing is going to get. So do you know in other programming languages, in C language, this can be maintained by using goto. Okay, in Java and Python, it is maintained by using while loop. So internally, the compilers will do this entire process into by using goto in the case of C language, and in the case of Java and Python in other languages, it will convert to while loop. Internally, compilers will do this tail recursion functions into while loop cases. So that what will happen? Even if these stack frames are there, what is the usage? Unnecessary, this data will be removed while coming out from this. Is there any advantage of using the stack here? No. But there are some situations where we are going to use that value. Such type of recursions are called as non-tail recursive calls that we will discuss later. So I think in the recursion, what is mean by tail recursion? What disadvantages are there with the help of tail recursion? You people got very clear clarity. Let me execute this. We are getting 3-1. Sir, is the concept is clear for you people? Please confirm.
So, sir, we can say that in tail recursion, we are not using any calculation type code, right?
Calculations we can do. Calculations we can do. See, even is this example is a tail recursion or not? This Fibonacci example. Yes, it is the tail recursion because so here it is not calculating, or we can say clear example this one. So last fact of n minus 1. After this, is it writing any statement? No. After this statement, if you have any other statements, it leads to non-tail recursion. So listen carefully in your function. Whenever you are writing recursion code, take the last line in the function. So if it is a recursive function, okay, so then it is called as a tail recursion. After that, you are not doing any activity. Or after that, if you are taking any print statement or any other SOP or anything, then it will comes under non-tail. I will take one example, sir. You will get clarity. Okay.
Yes.
Sir, clear up to this?
But sir, means the concept of tail recursion is that it is not backtracking. Means it doesn't.
It is not backtracking. It is not
Yeah.
backtracking.
So the concept is that the backtracking happens when there is some calculation to be done.
Exactly. Exactly.
sir,
What
if-
you have said is correct.
So we can say directly means we can imply that tail recursion happens when there is a print statement, right? Sir? Because it
No,
it doesn't
even calculation also no problem. Even
sir,
if you
because
are
in case of calculation only backtracks happen.
no, nothing. No, in the case of calculation, backtracking won't happen. Who said? So
because
in our previous example, if you see,
yes, sir.
factorial of 3 we calculated. So it is taking 3 into, so factorial of 2. So it is taking 2 into factorial of 1. So it is taking 1 into factorial of 0. You are telling this is backtracking, right?
Yeah.
No, that
yes,
is
sir.
not backtracking. That is not backtracking. This arrow marks why I have given. If you are calling function 0, it is giving output as a 1.
Okay.
The function return value I am tracking here. It is not backtracking.
For
So
the
when you are
yes.
calculating this, it is going to return 1 into 1 1. So this value will be returned here because it is a calculation. So it will return 6. Backtracking means what? For example, I called function 3. I calculated something. Okay. After that, again there is a function call. That means after printing this 3 to 1, again I want to reuse the values 1 2 3. Like this, if you want, you can write program for this. I will show you, sir. In the next case, you will get clarity.
Okay,
Don't
means
confuse.
we haven't touched the backtracking.
Yes, tail
right?
recursion, backtracking, we have not yet entered.
Okay.
So
was
the
back-
shortcut is, it is very simple, sir. At the last, whatever function name is there, if that function name appears at the last, then such type of recursions are called as tail recursion. I will go with non-tail, then you will get clarity. Sir, I am taking example for non-tail recursion. Non-tail recursion, I am taking one example. Then you people will get clarity. Now see, sir. Sir, I am taking the same function. Listen carefully. If n is less than 0, I will return. Then I am going to call function. After that, I am taking printing of n. This is called as backtracking. This is called as non-tail recursion. Sir, last statement, is it a function call? No. So how the execution flow will be? Sir, first it is going to call function of 3. What will happen? Sir, it is internally calling function 2. So it is internally calling function 1. It is internally calling function 0. Sir, when n is equal to 0, the program got stopped. But have you observed? We have one more statement is there. Now backtracking will happen. So in this case, this is stopped, right? Now backtracking is coming. When executing this line, already this method called completed, this statement is pending. At this line, what is the value of n? 1. Now this completed. Now backtracking. At the time of this line, what is the stack frame n value? It is nothing but a 2. Now it will print. Now at this line, what is the value of stack frame? N is equal to 3. Sir, it is going to print like this. If you see, the output of this program is nothing but 123. If you want, you can cross check. But how the control came? 3 and then 2 and then 1. So while coming, you can print. You will get 3, 2, 1. While going, if you print in the reverse direction, we are getting 1, 2, 3. I think you are getting some concept. So wherever reverse calculation is required, if you see backtrack, stack data structure, they are going to use. Sir, I want to check whether the given string is palindrome or not. Better to go for recursion. I want to check whether the given number is a string or palindrome or not. Best program is nothing but recursion. I want to calculate reverse of the given string, reverse of the given number, reverse of the given linked list. So reverse of anything, sir, this recursion is going to give the best result, because if you move from the beginning to ending, it will give reverse. If you move from the last to first, it is going to return normal values. I think you people got very clear clarity how this particular non-tail recursions are going to work. Clear?
Sir, could you please repeat that diagram once?
Sir, here first we are calling function of 3, sir. Right? So it is
Yes.
a calling function of 2 without calculation or without doing any activity. It is internally calling function 2. So this line
Right.
won't execute. Again, it will come to here. Then what will happen? It will call for f of 1. Again, it is going to call for here. So then it is going to call f of 0. When the value of n is equal to 0, return. So it will come out from the function. Don't
Yes.
assume that the program got completed. No. If you see, there is one line which is there in the 5th line. This 5th line never executed, right?
Yes.
So this data is there in the stack frame. When it is coming back, it is going to execute that instruction. So latest value of n is nothing but what? 1. That value will be printed. Then coming back, when n is equal to 2, it will print that statement. When n is equal to 3, it will print that statement. Because when n is equal to 0, simply we are returning, we are not going to print that data. Got it?
Yes, sir. Got it. Got it.
Sir, but there is no any such means it is kind of similar to for loop or any loop, right, sir? Because first it is calling the function of n minus 1, means first it goes for the recursion, and then at last it is printing the n. So how
Sir,
it is?
this example alone you can imagine with for loop or while loop. But this is the basic program. Such a type of complex situations, complex programs, if you are getting, then you
Yes.
can't convert that program into loops, because here the task is very simple. That's why you are imagining. So I is equal to 1, I less than or equal to 3, I plus plus, we can print like that. But this program, just I am trying to explain. Like that, if you have a big program, you can write only 5 lines code in the recursion. But in the loop, those many lines of code we can't write.
No, sir,
Got
means,
it?
yes, sir, but what I'm trying to say that, what I'm trying to ask that, sir, first it is calling the function, means before print function, it is calling all the numbers like 3, 2, 1, and then it is printing one by one, or because in the print function, the argument which is given over there is just n. So how it is working, sir, after?
That's what I am telling, sir. You are not listening the class, I think so. See, we are maintaining a stack, right?
Yes.
So first we called function 3.
Yes.
Okay. So
Yes.
we are calling function 3. At this line, what is the value of n?
And 3.
This is the first method call that we made. Okay. Then it is coming here. Is your n value 0? No. Then it is calling n minus 1. That means for this fresh call, right? Now it is going to call f of 2. Is it correct?
Yes.
What is the value of n? Next, again, it will be called the same function. So it is going to call for f of 1. What is the value of n?
1.
1. Now f of 1 leads to, so f of 0, right? Next method call is f of 0. Okay. So
Yes.
in the f of 0, what is the value of n? 0. Simply it is going to return. There is no method call again. Simply it is going to return. So these values are already stored in the stack frame. Now the program got completed. It will come out from the function. But if you see, there is one statement left. How many times this statement will execute? How many stack frames are there? Those many times we have to execute because it is there in the part of a program. So when you are calling with f is equal to 3, 3 times you are doing your job, 3 times you have to execute this print statement. In which order it will execute? If you print and then if you call the function, so you will get in your calling order. In your calling order, that is 3 to 1. But first you are calling, then at the end you have taken this. That's why, sir, it is coming backtracking. So when f is equal to 1, it will print 1. Then backtracking, f is equal to 2, it will print. Then backtracking, f is equal to 3, it will. Clear?
So by the concept of backtracking, it is printing 1, 2, 3, right?
Yes. Now my question for you is, can you please tell me where we are getting this n value, from which resource we are getting this n value?
Stack memory.
That's all. That is the reason why we are going for recursion.
Sir, the last part I did not understand, sir. After f of 0, print only will be executed once, right?
Print only,
0
print will
and-
execute how many times? 3 times. Because is
Sir,
these
but
lines
every
are
time
going.
function, but every time function is getting called. First time,
That's what. If a function is calling 3 times, after this function only this statement is there. How you will execute only 1 time? Are you getting my point? You are telling, you only telling this line will execute 3 times. Then how you can say this line will execute only 1 time? How many
Therefore-
times you are executing this one? Those many times you have to execute this. Correct only, right?
sir, but like when we have given input argument as 3, so control will come to f of n minus 1. And
First
then
time it is
again a
coming
function
here,
for-
right?
Yes, again a function.
Second time it is coming, right? Third time it is coming, right?
So print statement didn't execute, right?
That's what I am telling. So task got completed, then one statement is pending. For every method call, it will execute the print statement. That's what I am telling from the beginning, sir. It will store the information in the stack. Based on this, it is going to fetch the value and it will print.
Okay.
Okay.
Like in last, then it will. So for f
For
of
last method call, whatever we have made,
f of 0,
from
so
that it
0,
will
1,
take 0 means it will terminate, right? It is not
okay, so
printing
1, 2,
anything
and
for
3,
0.
1, 2, and 3. it will
Yes,
print.
for 1 it will take, and 1, 2 it will take for 3.
Oh,
Okay.
I got it, sir. Thank you.
Sir, we can call non-tail recursion every time follows the backtracking.
Yes. Suprit, please concentrate on the recursion. Now is that the queue concept is required here? No, right? That we will discuss later. So this is nothing but what we have. Sir, here I'm not going to continue this tail and non-tail recursions. One example is sufficient for you to understand. So how backtracking is going on and how our normal functions are getting executed. Okay. Now I will go for the actual programming part. From here, we are going to get more programs. So please concentrate on the programming part, how we are going to get. Okay. Does a Fibonacci and a factorial comes under tail recursion? Sorry, indirectly it comes under tail recursion. If I go for that concept, you people are going to get confused. As of now, ignore that. Okay. Please ignore that tail recursion concept from your mind. Remember only 2 points. What is the first point? So before function call, if you are taking anything, then it is called, I mean, in the function, if you are taking last method, if you are taking last one as a function call, then it is nothing but tail recursion. After that, if you are taking any statement, then it is nothing but non-tail. Okay, please wait, sir. 1 second, please wait. Right. So let us go for programming for this recursion. Okay, programming for this recursion. Let us take some examples. So the first example, I want to print, okay, program to print. So numbers, natural numbers from 1 to n. Already we covered this program. I think nothing is required to explain. Okay, directly I will write the code. Sir, we know very well, right? How to take this? I'm going to define a function which will take the value of n, and if your n value is less than or equal to 0, then we are going to return the control. We are not printing anything. Otherwise, we will call the function and at last we will print the value of n. So that what will happen when we are calling function with 3, it is going to print first 3, then 2. No, first it will print. So this recursion calls and it will keep on calling up to n is equal to 0, and it will come backtracking, and we are going to get the values from 1 to 3 like this. So this is the program how you can able to print natural numbers from 1 to n. Sir, same program, second example I am taking. Sir, I want to print the numbers. So from n to 1 in the reverse direction I want to print. Sir, what we have to do? The program is the same. The only task is nothing but you need to first perform print operation. Later you have to take n minus 1 so that it will print the values from 3 to 1. This is nothing but how to print the natural numbers from 1 to n and from n to 1. I think these two programs are clear for you people. Can you please confirm, is this concept is clear? Is these two programs are clear? Please confirm. Right. So next one, example number 3. What is the third example is, I want to calculate sum of digits. I am going to give a number. You need to calculate sum of digits of the given number. Let us define a function fun. So which will take a number n, which will take a number n. If that number is less than 10, means what? It is a single digit number. Directly we can return that n. If it is not a single digit number, I am calling. So we are going to call n percentage 10. Okay, n percentage 10, and then we are going to call the same function by passing n double slash 10, and assume I want to calculate function by passing 253. So what output we are expecting? 2 plus 5, 7, 7 plus 3 is nothing but a 10. So if you want, I will explain how it is going to work. See here, it is going to call for, so 253. So what will happen? It is going to calculate, it is not less than 10. So n percentage 10. This is the n. Percentage 10 means we know last digit is nothing but 3. Again, we are going to call for 25. So what will happen? Since it is a recursion, we will get last digit 5 plus it will be called for, so function with 2. Sir, since function with 2, n is a single digit number less than 10, it will return n. What is the n value? 2. So 5 plus 2 will become 7. Who called this one? For 7. So 7 plus 3, 10. It is going to return 10 as the output. If you want, you can see. So we are getting 10. This is the way how you can able to calculate, so sum of digits, sum of digits. Now my requirement is example number 4. So I want to calculate sum of n natural numbers by using this recursion concept. Sir, how you can write sum of n natural numbers? So here I am taking function n. If your n is equal to 0, so then we are going to return 0. Okay. Otherwise, what we have to do? We are calculating n plus function by passing n minus 1. So if we are giving the natural numbers as a 10, we are expecting the output as a 55. Okay. So, but for understanding, I will take only few numbers and I will share. Sir, a function of, assume I need to calculate a sum of 4 natural numbers. What will happen? 4 plus it will be called for 4 minus 1, 3. So it will call 3 plus factorial function of 3 minus 1, that is 2. And here it will be called for 2 plus function of 1. And it will be called plus 1 plus function of 0. So when your n value is equal to 0, so it is going to return 0. 0 plus 1, it will return 1. 1, 2 plus 1, 3. So 3 plus 3, it is going to return 6. 6 plus 4, it is going to return 10. Is it correct? So 1 plus 2 plus 3 plus 4, is it going to return 10 or not? Yes, you can see it is returning 10. Like that it will work. So, but for 10, I think we are expecting 55. This is the way how you can calculate sum of n natural numbers by using recursion. At least now you people got some idea how we can work with recursion. Can you please confirm everyone, is these sample programs are clear for you people?
Sir, in the previous problem, you have taken the base condition n less than 10. Why can't we take an n less than 0 also, sir?
Here in this example,
Previous example.
here,
Yes, sir.
sir, you can think sum of digits means what? Digit means what? 0 to 9, right?
Yes, sir.
So in this example, if you see 25 is reduced to 2. Again, do you need to calculate for 2? Because n value is 2 means 2 is the result that we know, right? Getting the concept?
Yes. But in that while loop, while taking that while or for loop, we
Sir,
take
why
that.
you are talking about while loop and for loop in this? That is the loops, sir. That is different. Here we are intellectually, we are thinking and we are reducing the code. Again, if you bring that while loop, again, how I can explain both, sir? That is different scenario. Here it is going to maintain with the tricks. So there, these kind of situations want to be there. Okay,
Okay, sir.
right. Sir, I request everyone to please confirm clear. Someone is asking, sir, if you pass minus 120, what will happen? Sir, minus 120 means if negative test cases are coming, then again it will leads to infinite execution. Better to give a caution message that your input should be always positive integer value. Okay. Sir, I request everyone to please confirm, is this concept is clear for you people? Right, good, sir. So let's, sir, around 20 members are there, but only 3 or 4 people are keep on communicating with me. I don't know what about the remaining persons. So next program, So I want to check whether the string is palindrome string or not. String palindrome I want to check. See how beautifully we are going to write this code. Sir, I am going to define a function called pally. Is it palindrome? It will take a string and it will take a starting location and ending location of the string, sir. Okay, I will write the code later. Sir, I am going to take, is it pally of, I am going to give sir, SIR. What is the starting location of this string? 0. What is the ending location of the string? 2. Because you know S is located at 0th location, I is located at a first location, R is located at second location. Exact location we are passing. Now I am passing, is it pally of, I am giving MADAM, madam. Sir, starting location is 0, ending location 0, 1, 2, 3, 4. 4. So if you don't know that string, sir, dynamically the user is giving the string means you can take length of the string minus 1. Length of the string minus 1 we can take. Now see how it is going to work. Sir, here I am going to check array. If your start value, is it equal or if it is going beyond the limit, then we have to return true. Otherwise, I am going to return S of starting location is equal to S of ending location or not, we are checking. At the same time, I will call for pally function by passing the same string and I will take a parameter as a start plus 1 and the next parameter is end minus 1. That's all. Simple 2 lines of code. Now see how it is going to work for different cases. Sir, first we are calling pally by passing SIR, sir. What is the inputs? 0 and then 2 I have given. Sir, it will check array, is your start value is greater than end value? No. Then what will happen? It is comparing 0th location and sir, S of end. S of end is what? 2. So 0th location and second location. Is these two characters are same or not? It is checking. Sir, what about this value? Sir, false, right? Because these two conditions are not satisfied. Okay, these two values are not equal. And sir, we know very well, since we are applying and, if both are true, then only it will return true. Since one value is false, directly it will return false. Okay. Now, sir, I'm checking palindrome for madam, MADAM, like this I'm checking, and 0 comma the index value is 4. Sir, now first time it is executing. Sir, is the start value is greater than end? No. Then S of start is nothing but M, S of end is nothing but M. Both are same, true. And is pally. Okay, true we got. So and so what is the next one we are taking? So it is a pally of, I am going to pass the same string. Okay. 1 second. Right. Sir, I am going to pass the same string. It will take madam. Okay. And what we are doing, if you see start plus 1, what is the previous start? 0. Now it will be 0 plus 1. What is the previous and 4? 4 minus 1, 3. Sir, how it is going to call? Again, it is a recursion, right? Again, it is a recursion. Sir, it is going to check. Is the start value is greater than end? No. Then start value and end value are same. So one first location and then third location. Yes, both are same. Then true, and it is going to call for palindrome of same string will be there like madam. Okay, and I am going to pass a start plus 1. 1 plus 1 is a 2 and 3 minus 1 is nothing but 2. Sir, now is a start value is greater than or equal to n? Yes, greater than or equal to n. That means both came to the same position means what? Technically, sir, we have same values. We have same values. Then what will happen? It is going to return true. Directly it is going to return true. Sir, returned value is true, true and true. We got a true. Sir, true and true. We got a true. Who called this? For them it is going to return true. Okay. And for this we are going to get false. I think you people got very clear clarity. Sir, everyone please confirm, is this concept is clear for you people?
Sorry, sir, but could you please repeat that logic? Like palindrome start +1 and end -1. Why this is?
Sir,
Okay,
palindrome means
got it.
hmm,
Means
it
one
is
by
checking
one
the
we are moving
characters.
forward. Yes,
Hmm.
yes, got it, sir. Thank you.
Sir, everyone please respond, sir. Clear up to this?
Yes, sir.
Yes, sir. Yes, sir.
Right.
Somewhat tree-like structure is games.
Yeah. So clear, right, everyone? Shall we go for the next one?
Sure.
Hmm. Right. So let's go for the next program. What we have here, I think with this, so you got some idea how we are going to work with these particular things. Okay. Now I want to write the next one, next program, example number 6. Sir, I need to write a program to calculate factorial of the given number. Okay, I want to write a program to calculate factorial of the given number. How you can write? So DEF, already we have written this code, nothing is there to explain. If your n value is equal to 0, then we are going to return 1. Otherwise, what we are going to do, we are going to return n into factorial of n minus 1. No need to explain this concept because several times we have calculated factorial of 5, so factorial of 4, so factorial of 0 I am taking. Now let us see what will happen. So 120, 24 and then 1, like this we are going to get. So I'm not asking any doubts regarding this because you know several times from the day one we are discussing about this one only. Next program, I want to calculate a power b value. Okay, so a power b value. Okay, this value I want to calculate by using recursion. Let us see how it is going to work by using recursion. Sir, I am going to define a function called power which will take a comma b. Suppose if your value of b is equal to 0, then I am going to return 1. Otherwise, I am going to return a into power of, I will send the a value as the same, but b value I am taking b minus 1. Now I am trying to calculate the power of 2 power 0. So 2 power 1. Okay. So 2 square, 2 cube, 2 power 4, 2 power 5. Let us see how it is going to work. Sir, I will dry run this code for 2 power 3. So we are calling power of 2 comma 3. It will check is your b second argument is 0 or not. No, then it will return, so a into a value is 2 and it will return 2 into, so power of 2 comma 3 minus 1, that is nothing but 2. So it will be called again 2 into, so power of 2 comma 2 minus 1 1. Sir, again it will be called 2 into power of 2 comma 1 minus 1 0. So when n is equal to 0, what will happen? When b is equal to 0, it will return 1. 2 into 1, it will return 2. 2 into 2, it will return 4. 4 into 2, so it will return 8. 2 cube is 8 only, right? Like it is going to calculate. This is the way how you can able to calculate 2 to the power, not 2 sir, any value you can give, a to the power b. This is the way how you can calculate this particular thing. Sir, can you please confirm, is these examples are clear up to this whatever we covered?
Yes, sir.
Right. Right. So another some 3 programs are there. So we will continue. Just I need break for 5 minutes, sir. So because continuously I'm speaking, just give me some 5 minutes break. So we will meet after break. Okay. Yeah, maximum I will take up to 995 like that. I will wind up. Okay. Don't worry. Yeah, so welcome back. So can you please confirm, am I audible? Is my voice is clear? Please confirm.
Yes, sir.
Yes, sir.
Right. So let's go for the next one, sir. I want to go for prime number. Okay, prime number application. I want to check whether the given number is prime number or not. You know very well about this prime number, right? Just we are going to write is a prime or something like prime. We will pass two arguments. Based on that, we will decide. Sir, I'm going to print, is it a prime number or not? What is the first number that I'm giving is 4. Second argument, make sure half of the number that we have to pass. There is one logic. If you are checking, so whether a number is divisible by a particular number or not, means don't take all the divisors. If the number is 100, don't take all the numbers. If a number is divisible by 50% of its numbers, definitely it will be divisible by remaining 50%. That logic I am taking. So if it is a large number, then this application is going to work. So if we are checking a number 50 is prime number or not, then don't go for up to 50, don't divide. Try to take exactly half, that is 25. If it is divisible by 25, it will be divisible by 50. If it is divisible by 24, it will be divisible by 48. If it is divisible by 23, it will be divisible by some other number. Have you observed such type of logic here we are taking? Sir, if you take 5, 5 by 2. If you take 6, 6 by 2. So the first parameter is the given number. Next parameter is half of the number. If that number is equal to 1, then we can return true. Yes, it is the prime number. If it is not 1, then I'm going to check whether that n is divisible with I. Then we are going to return it is not a prime number. Otherwise, we are going to return prime by passing n and we are going to send I minus 1. That's all. Sir, I will execute, I will try run this code for prime number. Okay, for prime number of I am taking for 4. What is the next argument to 2? So first time, is your I is equal to 1? No. Sir, is n is divisible with I? Yes. Then immediately it will return false. Sir, no need to go for further divisions. Next case, I am checking 5 comma 5 by 2 is 2. Sir, is the number is equal to 1? Second argument? No. Is that number is divisible by 2? Yes, it is divisible by 2. No. Then what will happen? It will call prime by passing 5 and 1 value we are reducing. Now you can see, sir, is it divisible? Sir, is the number value I is equal to 1? Yes. Then it will return true. It is a prime number. It is not a prime number. If you take a prime number for 6, 6 by 2 is nothing but 3. Sir, is your number is equal to 1? No. Is that 6 is divisible with 3? Yes. Then immediately it is going to return false. It is not a prime number. If you take prime number for 100, so 100 by 2 is nothing but 50. Sir, is the is equal to 50? 1? No. Is 100 is divisible by 50? Yes. Then it is going to return false. It is not prime. Sir, same program, if you do by using loop, so you have to start from I is equal to 1 and you have to divide up to 100. So 100 divisions you are going to take. So from that we are going to make the decision called false. But in this example, only one division, one condition we have verified. From that we are deciding the value called false. Sir, which is efficient when compared with the loops? In this scenario, it is efficient, right? Like that we can check. So let me run this code, whether it is correct results or not. False, true, false. Yes. I think you people got very clear clarity about how we are going to work with this. Can you please confirm any doubt, friends, up to this? Clear, everyone, please confirm.
Sir, is that mathematics rule, like we are dividing by 2?
Yeah, yes, sir.
Okay.
Right. So next one, what we are going to discuss here is, sir, I will write a program. I think already we discussed about this. Just I will directly write the code. That is nothing but a Fibonacci number, sir. Okay. So Fibonacci number or Fibonacci sequence I want now. I want to generate a sequence. But we know that recursive calls, right? We are going to take a FIB of n. If your n value is equal to 0 or if your n value is equal to 1, then we are going to return 1. Both I am going to combine into a single. Otherwise, I am going to return FIB of n minus 1 plus I am taking FIB of n minus 2. So what will happen? I will write a loop for I in the range of 11. Sir, I am going to print FIB of I followed by end is equal to space. So it will give all the Fibonacci sequence number. If you want, you can see 0, 1, 1, 2, 3, 5, 8, 13, 21. Like that, it is going to generate all the numbers. I think you people got very clear clarity how this Fibonacci sequence is going to work. Okay. Next example, I want to calculate reverse of a string. Sir, I am giving a number or any string. I need to calculate the reverse. How you can do? I am defining a function by taking a string. If your length of the string is equal to 0 or your length of the string is equal to 1, then I am going to return that string. Otherwise, I will return reverse of, sir, s of 1 colon till the end. Okay. So plus s of 0, s of 0. Like this we are going to take. Like this we are going to see. Sir, let us execute this code how it is going to work. Sir, I am going to print. So function of, I am going to pass the value called Prakash. So here also we need to take the function fun. Sir, let's see what will happen. Okay. Sir, first we are going to call for ABC. Let us take a function by passing ABC I am giving. Sir, is that string is having length 0 or 1? No. Then it is a calling function. So by passing, so s of 1, 0th location, first location, second location. From first location to the till end. And place s of 0. What is a s of 0? A, right? Like this we have. Then this one is going to call. This one is going to call BC. Is it having length 0 or 1? No. Then it will be called f of, this is 0, this is 1 from first location. That means C plus it is going to take 0th location character, which is nothing but B. Now f of the string is a C. Is it having length 0? No. Is it having length 1? Yes. Then we are going to return that string. I think here method call is not required. So what will happen? It is going to return the value called C. Okay, the value called C. Sir, what will happen? This result CB, right? CB, right? Then I am going to append that to A. Sir, CB, it will be returned. CB plus A is nothing but what? CBA. Is it reverse of the given string or not? Yes. Like this we are going to get. Now let us see what will happen. Sir, we are getting H something like this. Sir, what will happen if I take this S of 0 at the beginning? Let us see what will happen. We are going to get the original string. Have you observed in the beginning which logic first example we have taken? The same concept I applied here. Sir, I request everyone to please confirm. Is this last example? Is it clear for you people? Clear? Everyone please respond. Right. Sir, with this almost recursion got completed. So another big examples, some big problematic examples. I want to take some big problems, at least some 3 or 4 applications I will cover tomorrow. Okay. So tomorrow I will wind up this recursion. Tomorrow I will wind up this recursion. Okay. Sir, maybe Tuesday I may take again 2 hours a session. Okay. Tuesday I may take 2 hours a session, that I will inform tomorrow. Timings is the same, 8 o'clock, but maybe some half an hour or 1 hour before I will start. I will inform you that tomorrow. Okay. So with that, tomorrow we are going to wind up the recursion. So then after recursion, we are going for backtracking. Okay, after recursion, we are going for backtracking. After that, dynamic programming, then string and sorting techniques will be covered. Okay, right. So thank you. I will upload the running notes within few minutes. You can download. Okay, right, sir. Thank you.
Sir,
Yes,
there are only 12 chapters, sir.
in our entire data structures.
How many chapters do we have, sir, total?
We have only these 12 chapters.
Okay.
Okay, na Badrinath.
No, sir. How many
Is
do
it
we?
okay for you?
No, sir.
No,
How
sir,
many do we
sir.
have?
We have still some chapters are there. Main topics are there. Trees, graphs, okay, linked
Yes.
list. Those things are there. We need to cover those also. Just tentatively, I have written our schedule for maybe 1 or 2 weeks. Okay. Yeah, sir. These strings. Okay, I'm planning on one Saturday or Sunday. Same like this, we are going to take a string because programs only, right? That's why. And sorting and searching, these will be covered in our regular topics. Okay. Okay, we will plan for the future classes tomorrow. So with this, I will stop the session and I'm uploading the running notes within few minutes. Video also will be uploaded. Okay, thank you.